Hey guys, I realized that the videos that I made from class aren't the best because they are lagging and you can't really see what I'm doing in real time. So I decided to make a recording of some of the common questions that you guys had today. Nobody had questions on 1 through 3. All you had to do is cross multiply and solve for your variable. Those are kind of self-explanatory. I did want to go over number 4, and I'm writing this on my computer screen. So I'll try to be as neat as possible, but no promises. To be similar polygons, corresponding angles must be congruent. Let's see. And corresponding sides must be proportional. Okay. From here, these questions are going to make a little bit more sense. Do not do question 7. Didn't have enough information. So number 5 says the scale factor of MNOP to ABCD. What is it? Okay, so this is your old, this is your new. Oh. So your old figure is this MNOP, your new figure is the ABCD. And going from old to new, the figure is getting smaller. So you know when you get to your scale factor, it's going to be a fraction. So remember that scale factor, or K, equals new over old. That's the ratio you're looking for. So if we look at, I'm going to pick out this side BA. That matches up with this side NM. Okay, so if I do new over old, that's going to be 4 over 6, and that's going to reduce down to 2 over 3, so 2/3. Okay, is just 2/3. Okay. On number 6, you're filling in that statement of proportionality. So you have to look at the placement of these letters. I like to stack them on top of each other, like this, so I can see what goes with what. AB goes with MN, BC goes with NO. Okay. And then CD goes with OP, and DA goes with PM. Right. Again, you didn't have to do number 7. Number 8, a lot of people asked about this question. So using basically the ratios from question 6, you can set up several different cross multiplication problems. So I like the fact that on A, B, and MN, we have both of those letters. So I'm going to use that. So BA, or AB over MN, is going to be 4 over 6. So basically, if we took this and we filled in the numbers. Okay. So the first thing you're trying to find y. Okay. So the 4 is part of the new figure. The 6 is part of the old figure. So I'm going to keep that consistent. So it looks like the 8 lines up with the y. So I'm going to do 8 over y. And then just cross multiply. You get 48 equals 4y. Then you get 12 equals y. For z, that's going to line up. That's on side, let's use a different color. that's here. That lines up with this side. So again, I can use this 4/6 fraction. 4/6 equals 6/z. Cross multiply. You end up getting 9 for z. Okay. Number 10, it's important to note that the 3 theorems to prove triangles are similar would be angle-angle similarity, side-angle-side similarity, or side-side-side similarity. Okay. Somebody asked about question 11. So looking at this, it says, as shown in the diagram below, triangle ABC is similar to triangle DEF. AB equals 7x, BC equals 4, DE equals 7, EF equals x. So what you have to do here is set up a proportion. What matches up with what? And you can use this to figure that out. It looks like AB matches up with DE. What are those numbers? AB is 7x. DE is 7. And then it looks like BC lines up with EF. What are those numbers? Looks like that's 4/x. So you're going to cross multiply. You get 7x squared equals 28. Divide by 7, you get x squared equals 4. Take the square root, you get x is 2. Question asks you, what is the length of AB? You have to plug in a 2 right here. So 7 times 2 should give you 14. Okay, let's keep moving. On number 12, you have to figure out which set of triangles that are not similar to each other. Looking at 2 and 4, you can easily see that number 2 is angle-angle. Oops. Sorry, guys. So this is angle-angle because they have 2 angles. Number 4 is side, angle, side. Side, angle, side. So now we just need to compare 1 and 3. So what I like to do for these is I like to kind of categorize my sides as small, medium, or large, or just small and large, depending on what you're given. On number 1, this side is going to be the larger side, 12, and then the smaller side is going to be 9. On this other triangle, the larger piece is 4, the smaller piece is 3. So compare those. So let's do 12/4. That's going to reduce down to 3. Then if you do 9/3, that also reduces down to 3. And they have a angle in the middle of those two sides. So number 1 is actually side angle side similarity. Number 3 is the one that ends up not working because when you compare the small and the large sides, this is small, this is large, small and large. So if we do 32/8, that gives you 4. Okay, then if you do 16/2, that's going to give you 8. 4 and 8 are not the same. You can stop right here. That tells you the ratio of the sides, that ratio is not reduced down to the same fraction. So number 3 is the set of triangles that cannot be proven similar. Again, kind of what you have to do on 14. Categorize each side as small, medium, and large, and then set it up. So compare it to this. So the small side on number 1 would be 3. So that's going to be 5 over 3. And then you're going to have 12 over 4. Then you're going to have 13 over 5. And none of those end up reducing down to the same thing. So you know it's not 1. So do that same thing for 2, 3, and 4. What's going to happen is you should get the same fraction every time. Okay. Let's see. Somebody wanted to go over these in 5th period, so those were new. Basically, on 22 and 23, you're telling me, is it a reduction or is it an enlargement? And what is the scale factor? So on 22, it tells you in the directions. You're going from figure A to figure B. So the old figure is figure A, the new figure is figure B. On 22, going from A to B, it's getting larger. So this is an enlargement. To find the scale factor, I'm going to look at this top side here. This is 2 units. This is 5 units. So remember, scale factor is new over old. The new figure, B, has a side length of 5. The old figure has a side length of 2. So the scale factor is 5 over 2. And then 23 is also an enlargement because you're going from this small square, square A, to this larger square, square B. Sorry, that's awful drawing. So this is an enlargement. And again, I'm going to look at side lengths. This top side is 2. This top side is 5. So again, going from new, which is 5, to old, which is 2, that's your scale factor, 5/2. Okay, I hope this video helped. Tomorrow we are going to go on to the next section, right triangle trigonometry. Remember, Sokotoa. I can spell. Let's do it like this. Okay, and that's where you had to use your trig ratios. Okay, I will see you guys tomorrow.